So we're talking about applications of exponentials. We're looking at 4 different formulas. You should have done all 4 of these formulas before, so hopefully it's not brand new. So the first one is the one that we looked at yesterday, which is just y equals a times b to the x. So what you have to do is decide which formula you want to use when. So you use this one if you're given a graph, like those problems that we were doing yesterday. So then our next formula is a equals p times 1 plus r over n to the nt. So this equation is when you're talking about some kind of money. So maybe a loan or maybe an investment. But the question will say something like compounded and then something. So it might be compounded yearly, it might be compounded monthly, but it's going to be compounded and then a length of time. Okay. The only time you don't use that equation is when you use this formula, a equals p e to the rt, and that one is also talking about money, okay? But it'll say it's compounded continuously. Okay. So if it says compounding continuously, you use PERT. So a equals PE to the RT. If it says it compounded anything else, you're using the first big one right there. Okay. Have y'all seen these before? Good. Okay. So then the one that you're going to use most often is y equals a, little a, times 1 plus if it's growth minus if it's decay. Okay, so you have to choose, is it growth or decay? If it's growth, you use plus. If it's decay, you use minus. R to the t. So we're going to define the variables. The only one that I don't have down here is this little a. So this little a is just the starting amount of whatever you're talking about. So if you're talking about population, it's your starting population. If you're talking about bacteria, I don't know, whatever. It's just the starting value. Is that a, little a. So then the other ones, the big A, which are in 2 and 3, is your amount at the end. So if you're talking about an investment that lasts for 5 years, A, it would be how much money you would have after those 5 years. Do what? Yes, it's your total, yeah. So P stands for principal. Which is just another word for your starting amount. So maybe you start an investment with $500 or something. That would be your principal. So however much you're starting with. Now R in all of these equations is your rate. But you always want that rate as a decimal. Okay? So if it gives you a percent, you have to make it a decimal. And to do that, you can either divide by 100, or you can just move the decimal place 2 places to the left. And T is your time. Usually in years. In 2 and 3, it has to be in years. In equation 4, it doesn't have to be in years. But in 2 and 3, it's got to be years. And then N, which is the N in number 2, that is the number of times per year. So if my problem says we have interest compounded yearly, how many times a year is yearly? 1 time a year. So then our yearly would be 1. If it says monthly, how many times a year is monthly? 12. Good. How about quarterly? 4. Good. So think quarterly like a quarter. 4 quarters in a dollar. Quarterly. Okay. So then the only thing that we haven't defined is E. And E is not a variable. E is a number. So it's a number like pi. So on your calculator, if you hit second division, you get E, and there it is. So E is a number, and we'll look more at E in the days to come, but it's a number. So 2.718, etc. Okay. And again, to get that, you hit second, and then division. Okay. So you had to figure out which equation you want to use, plug in for all your variables, and then we'll just solve it. Today they're pretty easy. We'll talk more about solving later. So let's look at the first one. So the first one says population of the popular town of Smithville in 2003 was estimated to be 35,000 people with an annual rate of increase of 2.4%. So we want to write an equation to model it, and we want to estimate the population in 2007. So is this one talking about money compounding? No. So is it a graph? No. So then we want to use equation number 4. So we have to decide, is this talking about growth or is it talking about decay? Growth. How you know? Good, because it says increase. So that tells me it is growth. So then I need to use y equals a 1 plus r to the t. Okay. So if A is our initial amount, our starting amount, what is our initial population? Good, 35,000. So then we need R, which is our rate as a decimal. What would that be? Good, 0.024. Good. And then to the T. So this would be our general formula. So with this formula, we could estimate the population in any year. Okay. But we're starting in the year 2003. So 2003 is when our time is 0. That is our starting year. Okay. So if I want the population in 2007, how many years later is 2007? 4. So then we plug in 4. I'm going to make it 1.024. So you're just adding those together to the 4th. And then we just type it in our calculator. and hopefully you get this. And so it tells me to round to the nearest 100 people. So what would that be as the nearest 100 people? So, okay, I have 38,482. But if I wanted to round to the nearest 100, good. So then to the nearest 100 would be 38,500. Good. No. 100th is the decimal place. With a th at the end. TH. Question on that one? Or else I got 2. So number 2 says Marissa invests $300 at a bank that offers 5% compounded monthly. How much will be in her account after 20 years? So if this is compounded monthly, which equation do I need to use? The second one. Good. So A equals, how much is she starting with? 300. What's the rate as a decimal? 0.05. And if it's compounded monthly, how many times a year is monthly? 12. So that goes in 2 places. That goes in the denominator and in the exponent. And 12 times, how many years is she leaving it in there? 20. She is looking at the future. Alright, so let's see how much she's going to have. So to type it in, you got 300. 1 plus, you can just use division, but to get the fraction, alpha y equals enter. 0.05 over 12 to the 12 times 20. So if this is money, how would I round it? Good. So $813.79. Yes, you want to round it to however it tells you or whatever makes sense. So like for money, you want 2 decimal places. You could, yeah, it'd be okay. Alright, so I got 3. 3 says Matt bought a new car at a cost of $25,000. The car depreciates approximately 15% of its value each year. How much will the car be worth in 10 years? So is this talking about something that's compounding over the years? No, it's just talking about it's depreciating. So is it growing or decaying? Decaying, good. So depreciates. So we want to say y equals a 1 minus r to the t. So what is the starting cost of the car? Good, $25,000. What's it depreciating as a decimal? Good, 0.15. And how long is he going to have it? 10 years. Good. So what'd you get? Good. Good. $4,921.86. Good. Oh, that's because, my bad. Minus, I'm sorry. It's depreciating. Sorry. Okay. I wrote minus, but then I wrote plus. Any questions on that? Alright, let's look at 4. So 4 says Jose invests $50,000 at a bank offering 10% compounding quarterly. Find the amount of the investment at the end of 5 years. Tamika invests $500 at a bank offering 10% compounding continuously. Find the amount of the investment at the end of 5 years. Who has more money at that time and how much more? So first let's look at Jose. So if his bank is offering compounding quarterly, which equation do we use? The second one. Good. So A equals, he's starting with 500, 1 plus 0.10, good. And if it's compounding quarterly, 4, good. So that goes in the denominator and in the exponent, and 4 times 5. So we're looking at 5 years. So how much is Jose going to have after 5 years? Good. $819. Good. And 31 cents. Any question about that part? Alright, let's look at Tamika. So she has $500 compounding continuously. So which one do I use continuously? Good. The third one. So A equals, she also has 500. E, remember E is the number, not a variable. And then the rate is the same, 0.10. And the time is the same, 5 years. So to type that one in, 500. Again, to get the E, you hit second division. And then 2E, 0.10 times 5. Enter. So she has $824.36. So who has more money? Good. Tamika has more money. How much more? Good. So she has $5.05 more. Questions? Alright, last one. So it says the growth of a colony of bacteria is given by this equation. There are initially 500 bacteria present, and T is in hours. So first we want to know, what is the growth rate? So if we look at this equation, what's the growth rate? Yeah, so 0.195. So what would that be as a percent? Good. So now we want to write an equation that models the data and determine how many bacteria there will be after half of the day. So this little Q sub 0 or Q naught, that is talking about your initial whatever. So in this one, it's our initial bacteria. So how many bacteria do we have initially? 500. Good. So Q equals 500 E 0.195 times, and then we want to know how many bacteria there will be after half of a day. So if it tells me time is in hours, how many hours is half the day? Good. 12. So then you just type it in. Good. 5,190. We'll round it up to 1 bacteria. Good, good, good. Question.